Hi guys, Colin James Poulter here once again, and welcome to my YouTube channel. Hi guys, well here we have one Fostex studio spec monitor. They're about 500 quid each to buy. It's a PM-2 MK2. They're quite old now, but back in the day they were built to last. And this is a friend of mine, head of music at the Hailing College, and he's had these a number of years, but this one has developed a nasty mains hum. I would demo it, but I'm sort of halfway through the repair. I wasn't kind of going to do a video for this, but after ordering some test equipment, which I need, I needed obviously to test the caps and test the diodes, stuff like that, which I haven't got because I don't normally do this sort of repair, but for him I thought, yeah, okay, we'll have a go. So yeah, it's a mains hum because if you switch it on with no leads attached, after a few seconds you get the classic at 50 cycles, both emanating from the bass driver and the treble unit. So I thought I'd give it a go and have a go at repairing it. It can either be a Duff bridge rectifier, something in the rectifier circuit, not kind of dealing with the AC from the step down transformer inside, or it could be leaky caps. Diodes rarely go, so I'm thinking, yeah, okay, after testing the diodes and confirming that it's not them, I'm now suspecting the caps. So in this video I'm just going to show you basically what I'm going to do to repair it. So let's get started. So here we go, this is the back of the monitor. It's a Fostex PM-2 MK2. You've got the usual stuff that you get on the back of these active monitors. And we got a rather large heatsink, and down the bottom we have the AC in and the power switch. What you'll need for this is there's quite a lot of screws around the outside edge of this thing, right, which have to be undone. So rather than trying to do it by hand, I've got my trusty cordless drill out with the correct fitting Phillips bit on the end. Now it's very important that your bit fits into this screw, into the head of the screw there, nice and snugly, because these are quite tight. You don't want it jumping around in there and ruining the top of your screw. I'll try and do this with one hand and hold the camera at the same time. I've also got my trusty solder, my flux, and I've got my long runner tester, and these are actually really good. You can get them off eBay. You can test triodes, diodes, capacitors, what's those, xenodiodes, resistors, transistors, NPN and PNP and all that. Really good. It's a long runner. There you go, just look it up on eBay, and they're not a lot of money, about 15 quid. So I had to order that obviously so I can test the diodes, which I've already tested. Here's one of them. It's an N, can't quite see the number on there. It's a N1, no sorry, a 1N5 something 02. Can't quite see that. Well, I can't while looking through the screen of the camera, but you can go online, look them up, and you can get access to data sheets, which gives you further information, and then you can compare the data sheet information online for this boy compared to the test results through your long runner kitty here. So I've already tested these two diodes and yeah, they're they're good, they're well within specs, so it's not them. Sorry, that was a bit blurry there. So I've got to put those two back in. Got my soldering iron. I haven't got any solder white pads, so I've just used baby white there, which is plenty good enough. So there you go. Oh, and also my trendy solder sucker, because obviously when I took these two diodes out, I need to heat up the solder around the holes on the board, and you know, suck the solder off and then remount these. Right, let's get cracking then. So what I'm going to do is go around and just buzz these screws out. There we go. Voila! Try not to let the bit skip on the top of the screw. Which I did mention before, to make sure that these will be tight when you first want to do them, especially if they haven't been off before. Anyway, so I'm going to go around and undo the rest of those screws, and I'll be right back. Okay, if you can hear a bit of whooshing or humming in the background, it's my desk fan. I had to turn it on because up here it's absolutely sweltering. Really muggy day today, even though we've had a bit of rain. So anyway, once you've undone all the screws around the outside edge, don't try and undo these because that holds the input socket in. Don't undo these two because it holds the switch in. Don't mess with these because behind there is the transformer, and obviously don't undo these because that's the AC plug. Just so it's just the outside edges, okay, only. Now you'll find that this back will be stuck to this like shit to a blanket. So the best way that I got this unit off the back of the speaker, don't try and put anything in between the metal plate and the cabinet to prise it, because you'll end up damaging the cabinet. The easiest thing to do is to turn the speaker completely upside down on its back and shake it, and this will just fall away. So basically turn it upside down like that, get hold of it with your hands either side. I can't do it because I'm holding the camera, and shake it up and down. Now don't pull it away too far, because don't forget the electronics in the back on that unit and that big heat sink, the transformer, will be attached to the speaker driver of the tweeter. And also there's a LED light here at the end of the Fostex, can't get the words out. There's an LED light at the end of the Fostex logo, so that'll be connected. So you need to just give it a shake, and then when you feel that bottom plate drop away, do it on a soft surface. I'm using our bed here at the moment. And that's how to get the back unit off. There's really no other way of doing it. Good shake, lift it about 1 inch, no more than that, and it will come away perfectly. Right, so once you've loosened this by giving the speaker a little shake and this falling away slightly, turn it back over this way up, and now you'll find that this whole thing is loose. Yay! Now what you need to do now is just lift it up slightly, and if you look under here, I've already done it, but if you look under here, there will be some wires attached. So just very gently manipulate it in a way that you can get your hands in there and just disconnect the LED power lead and the driver lead. Once you've done that, you can lift the whole assembly out, which I will do right now. Okay, we're in the back of it now. There's the mains transformer. there's the two big caps which I suspect. So it'll come off of here, go into the rectifier, go through these two caps. These are the two that I suspect. You can look around all the other caps if you want to. I mean, there's a little cross, well actually there's a big cross on the top of these. All these other caps have got that cross on them to give you some idea if they're blown. If they're blown or they're not good, sometimes that will be domed, or there'll be a hole in it, or there'll be some sort of leakage. So I'm not particularly interested in any of those at this particular time. The two I am interested in are these two caps here. So as you can see, there's some anti-vibration paste down there. So first thing I've got to do is figure out how to remove that. Once I've removed that, which I stuck the bottom of the cap to the board, then we can think about getting these off to test them. There's no point in trying to test them on the circuit board because there's loads of other components and bits and pieces going on, different pathways which may give you a false reading. So it's always good to take them away from all of this stuff and test them independently. So there's two leads which you've got to disconnect. There's one here, so you just push this tab in. I've already disconnected it, like so. One over here which just pulls off. Don't pull it by the lead, pull it by the actual plastic clip itself. That comes off. And then we've got 4 screws, one there, one there, one there, and one there to undo, and that should give us the ability to take this board away. Now if you look down there, you'll see that there are some screw holes. Now I've already removed these. This is quite important. Right, you have to unscrew them because under here you'll see there's a group of transistors which are actually screwed via heatsink paste or thermal paste to this big heatsink at the back here. So you've just got to make sure that you undo those as well, because you'll be undoing these 4 screws, yanking on the board, and unknowingly you know, putting pressure on those legs. So right, so I'm going to take this board off and then we'll come back to you. Right guys, sorry you're going to have to put up with the fan noise again because it's just really warm up here. The board's off, and as you can see we've got some thermal paste that's got to go back on those pads before we put the thing back together, because that's been on there a few years and it's gone a bit hard. I mean, once it's disturbed, if we put it back and screw the transistors back to the heatsink, I doubt if that will convey the heat to the heatsink as good as when it was new. So we will reapply some new paste to that, or to those even. So here's the board. Whoops, zoom you out a bit. So there was 4 capacitors here. I did measure them on the board and got varying degrees of values. So again, I thought the best thing to do is take them off, check them off the board where there's nothing else connected, and get some true values. In doing so, they're fine. Like I said in the beginning, it's very rare that these particular type of transistors prove to be troublesome. So as you can see, there's some solder there that's got to be cleared from the holes. That's why I've got the solder sucker. That needs to be nice and clear before the legs can go back in. And my main concentration is going to be removing these 2 capacitors. And they are, if I can see that, 6,800 microfarads at 63 volts. So we're going to see if those values indeed match up to the values in my meter over there. They have a resistance as well, which I can't quite remember what it's called. ES something, ESM, ESR I think it is. We'll check that as well on the data sheet that I'll bring up online for these caps. The first thing to do is to remove that paste. It's a bit like, remember window putty? before double glazing came along. It's like that sort of consistency. Right, and then obviously desolder at the back there to remove the caps. So I'm going to find out a way of getting rid of that paste and get back to you. Okay, well, I've got the solder sucker going, and I got most of the solder off the bottom of the capacitor legs. I was a bit dubious about, you know, how to go about getting this. It's really stiff, that white stuff. It's almost like glue, but luckily it's only stuck to the plastic heatsink around the can. It's not actually stuck to the aluminium part of the capacitor. So with a side to sideways wiggle like that, or just, you know, very gently stressing it that way and the other way, I managed to crack the plastic and actually get the capacitor out. Just leaning on one side, applying a bit of heat to the solder, applying a bit of heat to the leg, got one side off, pulled the other side off, and happy days. So let's have a little go on the tester. I've got the negative connected to the negative side of the cap, positive to positive, and let's see what we get. Well, we got very little resistance in the ESR. Okay, loss is about 0.9, and it's reading out at 6441 microfarads. That's 6441. So we'll just have a look at the cap. 6441. Take that off. 6441. What have we got on here? Oh, she's well down. 6441, 6800 microfarads. Okay. I'm going to say that is bad. Oh, that's good actually. Right, so what I'm going to do now is I'm going to try and get this one off. So I'm going to just try a little bit of side to side, very gentle, see if I can crack the plastic like I did on this kiddie. Or what I could do is get the scalpel and just go around the base of that plastic with a scalpel. I think just do a cut line, and then that will allow me to break it free of that cement stuff, and then we'll apply a bit of heat to one of the pins, give it a this way gentle pull, and then that should pull one leg out, and then apply the solder to the other leg and push it that way, and we should get it out a bit like I did with this one. Right, be back when he is out. Okay, so I've got the other one off. I made myself a cup of tea, come back, and I've forgotten which one was which, so I'm going to test the first one again. So wait for it to charge. It's supposed to be 6,800 microfarads, and in fact it's 6444. ESR is only 0.1, don't worry about it, but the loss is 1.9%. So that one's bad. Okay, let's check the other one. See what that is. A bit fiddly doing it while I'm holding the camera, but there you go. Yeah, see, it's supposed to be 6,800. 6,800, right. And this one, I think, is the same value. 6,800. Right, we'll hook this one up. Don't forget, negative on the negative. I don't think it actually matters when on the actual test, you know, this test meter, which way around they go, to be honest. Okay, here we go. So it's supposed to be 6,800 microfarads. And it's 6,4 0.23, loss of 1.3%, and it's 0.17 of ohm ESR. So I would say that that was bad as well, and that would explain why we're getting a little bit of mains hum coming through the speaker drivers. So there you go. I suspect these two. But don't forget, guys, before you check capacitors, make sure they're discharged, and you can discharge them, which I did with these. I didn't actually show you how I did it, but basically I just shorted out these two pins with a pair of pliers or anything conductive, just to make sure that there's no, I mean, fully charged, that will give you a bit of a belt, and it could damage your test equipment. So there you go. So now I've got to go on to the internet and see if I can find a pair of these caps, either RS or Maplin or eBay. Should be able to get a pair. So I've put the other two rectifiers back in place because I was quite happy that they're okay, and I've soldered them up. Don't even see that, or I'm too close, but there you go. It's good. They're good joints. And there's the power transistors, which I said earlier to make sure that you undo the screws before you lift this board off, otherwise you'll just end up bending the legs. So I think that is it. Hey guys, if you know what this stuff is, can you tell me? Because I have no idea. Let me get my bit of solder so I can point to it. It's this white, it's this white this white stuff. It looks, and it's quite dense, although you can scrape it off. It's a bit like white silicone, but it's more sort of white two-part epoxy, araldite, but it's not as hard. It's quite soft, but I don't know what it is. But luckily, because the bottom of the caps, the white stuff was stuck to the plastic heat shrink on the caps rather than the metal cans, it came away quite easy. I mean, I made a couple of cut lines with the scalpel so that when I stressed it broke the heat shrink, which allowed me to get the rest of the cap off once I desoldered it. But okay, well, I'm no electronics expert. I mean, but with reading about different components online and getting the right test equipment and knowing how to use it properly, I think it's helped me a lot repair this sort of stuff. Don't do it very often, like I said, but the stuff I did know about electronics is like so long ago now, I've just forgotten it all. But like I say, if you don't do something regularly, you tend to forget how to do it. Me, I tend to forget about everything. I can't even remember what was for dinner yesterday. So there you go. I hope this has been some help so far on repairing this thing, which again is a Fostex PM-2 MK2 powered monitor. Now, as I said before, this stuff in here has gone a bit hard, which is thermal paste, conductive paste, heat transfer paste, whatever you want to call it. So I will, when I order the new caps, order some of that to go back on these transistor bases, so that they can have a nice thermal coupling to the heat sink over there. Come on, camera, there you go. Right, that's it for now. I'm going to call this part 1. Part 2 will be put the new caps in and running it up and see whether we have in fact solved the mains hum issue. Right then, cheers for watching, and don't forget, if you have enjoyed this video, give it a thumbs up. If you're not subscribed, subscribe, and catch you later. Cheers in. Bye.